Equation is y equals mx plus b. Now, when you look at this, you're like, oh my gosh, Miss B, there are 4 letters and I don't know what to do. Well, it's important to remember what the letters stand for. Our m is our slope in the equation. Now remember, we have already learned how to find slope using the slope formula, but I'll remind you again that m is our slope, okay? Our b in the equation is our y-intercept, all right? Now, what does y-intercept mean? That seems like some fancy word. Well, let me remind you, our y-intercept is where the line crosses the y-axis. So I'm going to write that down. You should too. Where the, pardon, I have an alarm. Where the line crosses the y-axis. Okay, so we're not going over at all on the x-axis, but we do cross at the y-axis. Okay, so it's going to cross anywhere along here, but we're not going horizontally in any direction. All right, so how do we graph using the slope-intercept form? Well, let's say that we have a function and it's a linear function and it's in slope-intercept form. And just for example, I'm going to write one up on the board. Y equals 2/3 x plus 4. Oops, actually, let's make this a minus 4. Okay. All right, so it's a minus 4. And actually, let me just rewrite that for you. Y equals 2/3 x minus 4. I apologize. Okay, so we have 2/3 x minus 4. And you're probably thinking to yourself, oh no, Miss B, our slope is in a fraction form. Oh my gosh, what are we going to do? I hate fractions. I hate decimals. I hate anything but whole numbers. All right, take a deep breath. I actually prefer when the slope is in the fraction form because if you remember, slope is equal to the rise over the run. So when I have it in fraction form, it's telling me I'm going up 2 and over 3. It makes it super simple. When we're dealing with a whole number, we have to remember that a whole number is written over 1, and so sometimes that can be a little confusing. All right, so let's go ahead and get started with plotting this. So first, I would recommend plotting the y-intercept, okay? One y-intercept. And I apologize for my chicken scratch. It's hard to do this. All right, so our y-intercept. Well, what is our y-intercept? All right, remember, again, it's the number that comes after the x, and we are going to take the sign with it. So because it's -4, I need to go down on the y-axis, -4, but I'm not going over any at all on the x. So I'm going to count down 1, 2, 3, 4. And I'm going to put a nice big dot here. This is my y-intercept. All right. The second thing we need to do is use slope to plot the points. So 2 is use slope to plot the points. Remember, slope allows us to determine a bunch of lines or a bunch of points that all fall within on a line. So if I come over here, I'm going to look at my slope, and again, my slope is 2/3. So again, slope is the rise over the run. So 2/3. So that means first I need to go up to 1, 2 from my y-intercept, and then over 3. 1, 2, 3. I'm going to put another nice big dot here. I can keep doing this. Up to over 1, 2, 3. Up to 1, 2 over 1, 2, 3. Okay. If you notice, our slope is positive. There is no negative number behind it. But I can still go backwards from this point here, which was our y-intercept. Because if I were to have, and I'll write it up top here, -2 over -3, we could just cancel out the negatives. Remember, a negative divided by a negative is a positive. Same sign, positive. So I could go down 2 and over to the negative side 3. 1, 2, 3. And that would also, 1, 2, 3, that would also be a point that falls on my line. And you can see that here. So I could go down 2 again and then over 1, 2, 3. All right. So to recap, we plot our y-intercept, which we know is not going over at all. So it's 0 for our x value and then -4 for our y value. All right. Then we use slope to plot the rest of our points. Up 2 over 3 or down 2 to the negative side 3. All right. Last thing we need to do, number 3, you're going to write this down, is connect the points with a straight line. All right, easy peasy. So with your ruler, you're going to take your ruler, you're going to line it up along these dots here, and I'm going to make sure that my pen cuts through each of these, and there is my line. Okay, I connect it. I have just plotted the line, which is equal to y equals 2/3 x minus 4. Now, is this the line we would expect? Absolutely. Our y-intercept crosses at -4, like we saw here. And since our slope, 2/3, is positive, we would expect it to be increasing or going in the positive direction. All right. So the next thing I want to talk to you about, and just give me a second to rearrange, is to test whether or not a point falls on the line. So we have a pretty big raft here. Okay. All right. But we want to know if 12, 4 is on there. Kind of like if you were to play Battleship. We label our points. Well, if you look here, the highest point I get is 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. Okay, so this point right here is over 9 up 2. I can't see, using this coordinate plane, whether or not if 12, 4 is going to be on the line. But that doesn't mean we give up and say, oh my gosh, we can't do it. No, we can actually use our formula to determine this. So first I want to say, all right, I know it's x and then comma y whenever we are talking about a point, okay, on the line. What I want to do then is I want to take my formula, y equals 2/3 x minus 4. I have an x and I also have a y. So I have an x and I also have a y. So I'm simply going to replace the x and y values with these values in the point. So I'm going to say 4 equals 2/3 times 12 minus 4. Now remember, just like when we were solving equations, we have to make sure that they're equal on both sides. Remember, whatever we did to one side, we did to the other. Well, in this case, we want to make sure both sides are equal. So, obviously, this side remains 4. 12 times 2/3, if I were to put it into my calculator, would be 8. I can easily figure this out because 12 broken up into 3 equal pieces would be 4. 2 of them would be 4 plus 4, which is 8, and then minus 4. All right, so we multiplied these two together, 2/3 times 12. You have a calculator, you can do that. And then we keep the minus 4, we just bring it down. Well, we have 4 still on this side, and then 8 minus 4 is, that's right, 4. So yes, it does check. Because these numbers are the same, we know that, yes, this point falls on this line. And if we were to continue that, we would see that. All right. Let's look at this one though. Again, this goes beyond what we are showing on our coordinate plane. So I have to take a look and say, okay, how can I do this? Again, I'm going to label this as X and this is my Y, and I'm going to plug it into my equation right here, just like we did the last time. So again, Y equals 2/3 X minus 4. I'm simply replacing the X and Y values with X and Y's in our linear function. All right, so I'm taking then -6 equals 2/3 times -16 minus 4. Now, when I look at this, it's a little trickier, but again, you have a calculator. If I were to multiply these together, remember, all I have to do is put a 1 straight across the numerators and the denominators. So I will have -6 on this side, then 2 times -16 is -32, and then 3 times 1 is 3, and I still have my minus 4. All right. Now, again, you could use your calculator, but let's say, like on the PSSA, you don't have one. Don't panic because it's a fraction. Well, what's another way we can make -4 in which it would have a denominator of 3? Well, I can say -6 is equal to -32 over 3, or we're determining if it's equal to, and then the -4 could be minus 12 over 3, because 12 divided by 3 is 4 minus 4. Now I have something with the same denominator, so I can go ahead and subtract these fractions. So I end up with -6, and then 32 minus 12 is 20, -20, I'm sorry, and of course our denominator stays the same. If I were to plug this into my calculator, it would be -6 is equal to -6 and 2/3. They are very close in size. However, this 2/3 is still more. Since they do not equal each other, we say no, this point would not be on our line of Y equals 2/3 X minus 4. Okay. Oops, I am sorry there, guys. I've been doing that a lot. All right, so now let's take a look at our second page. And it's kind of dealing with word problems, which again is another thing that I know y'all don't like. So we're going to just take a look at that. Now, we've looked at